Okay, as we continue to look at how we use land, let's talk about urbanization. Urbanization is typically when people move into a city area. Urban means city, rural means country. Now, cities tend to have a lot higher rates of air pollution and water pollution, so why is it that people would want to move in them? Well, there's a lot more opportunities located within cities. Some of the opportunities are like education. There's a lot more variety of schools. Typically, some of your better schools are going to be put into a city. Same with your healthcare and medical services. You just have a lot more options, which is going to drive up competition. So you typically are going to have better healthcare options within a large city as well. Think about like if you're going to go to Duke or Chapel Hill or Wake Forest for medical stuff, you're going towards a city. There's also a lot more entertainment. If you live in the middle of nowhere, there's a lot of outdoor things you can do. But if you are looking for movies and shops, then they just don't quite have the same things, even with a variety of restaurants. And then lastly, social service programs. Social service programs are just going to be things that are set up to help your more lower income families. Think about like homeless shelters or soup kitchens and things of that nature. They're going to be located in a city so that they can reach more people and they're going to be closer to it. So those are all things that draw people into urban areas. So let's look at some of the effects of these urban areas as we turn land into cities. With more people, we need more land. You don't necessarily need to write this down, but we have already talked about how our population is growing extremely fast. And as it's growing extremely fast, we are needing more land for people to live on, as well as more land to grow food on to feed those people. So how do we make land or more room for land to use for these industry things? Well, we do something called deforestation. Deforestation is removing trees. So if you're chopping down all the trees in a forest, you are doing deforestation. We do this not only for resources, such as to make paper and lumber to build with, but we also do it just to make the space that the urban areas need. There are two ways of doing deforestation. One is called clear cutting, and one is selective cutting. And we're going to look at those two on the next slide, the differences in them. But when you're looking at any form of deforested area, whether you're doing clear cutting or selective cutting, you're still going to have higher rates of erosion and you're still going to destroy habitats. Because anytime you're chopping down trees, you're removing vegetation. Remember, the roots from the vegetation help to hold down and contain the soil. And then whenever you're getting rid of the trees, you're getting rid of some of the habitat. And we know habitat loss is one of the biggest threats to biodiversity. We replant trees, but that typically isn't enough. For instance, when you are looking at the rainforest and the rate we've cut down trees there, people talk about how, but we're planting trees back. But typically it's only one type of tree, and you were removing hundreds of different types of trees. So you've instantly removed the biodiversity, and we've already looked at how that can be a very bad thing. So let's look at the difference in clear cutting and selective cutting. Clear cutting is like what this top picture shows. It's when you just cut down all the trees in the area. You completely cleared it out. Selective cutting, on the other hand, is when you select some of the trees to cut down, but not all of them. This is the better option because, yes, you're still going to have some erosion, and yes, you do have some habitat loss, but you were able to prevent all the habitat loss, and you were able to prevent some of the erosion, as well as maintain some of the original diversity that was in that forest. So whenever it's possible to do selective cutting, it's a lot harder to do and a lot more complicated to do than just to go in and clear everything. But it is definitely a much better option. So with more people clearing more land, we're using more timber and we're increasing our carbon dioxide output. And so these things don't balance out. And the reason they don't quite add up is because, remember, trees and plants, they breathe in carbon dioxide and they replace it with oxygen. So they are a natural filter for our greenhouse gases. And so as we have more and more people, a higher population, we are using up more energy and we are increasing how much carbon dioxide we're putting out. At the same time, we are cutting down more and more trees. So we are also decreasing all the things that could naturally filter the carbon out of the air. So, and you can see from that graph, the rate of deforestation, as it increases, you have the rate of population increasing as well. And then right towards the end, you see it kind of leveling off a little bit, but it definitely is having an impact on one another. So these are just some pictures of what they call virgin forests that were located in the U.S., so forests who deforestation had never taken place in. And you can see over really not that long of a time, we ended up going into pretty much all of the forest in this country and having to cut down trees. That's not saying there's no trees left, but it's just showing that our rate of deforestation has definitely increased as we've had an increased need for it. Okay, and we're skipping this. So more people also means more habitat fragmentation. So as you urbanize, you not only clear land more from your deforestation, increasing your erosion, habitat loss, but we're also increasing habitat fragmentation, which if you remember from our biodiversity lab, that's one of the things that is a big threat to biodiversity. And that's when you basically cut roads and whatnot through habitats of different animals. And that's why, like on my way to work today, I saw a dead deer on the side of the road. So those are the things that habitat fragmentation leads more and more to. So a couple of other effects of urbanization is acid rain. If you remember way back when we talked about weathering and erosion, acid rain was one of the forms of chemical weathering. So we had two types of weathering, mechanical and chemical. Mechanical, all the things the rock keeps their original composition, and then chemical, it changes it into one or more new compounds. So you're going to have more and more chemical weathering because of acid rain from urban areas. And that's because when you have your urban areas, you're going to have more pollution. And the pollution we're looking at is not necessarily trash on the ground when we talk about your acid rain. We're talking more about fumes that are put into the air. So I want you to picture you have carbon dioxide being released by the fossil fuels that we're burning. That carbon dioxide is now in the air as a gas, and it can mix with the water vapor, which is also a gas, to combine to create what we call carbonic acid, which can then come down in the form of precipitation, thus giving us acid rain. So the more urbanization you have, the more air pollution you have, which can then lead to more acid rain being formed. And acid rain doesn't only cause increased weathering, like you can see from the statue down here, but if you look at the trees that are stripped of vegetation at the top, this is another effect of acid rain. Your acid rain can also make bodies of water more acidic, which can affect fish. And remember, we did talk about this before, but don't think of acid rain as like hydrochloric acid that's going to come down and just burn your skin off. Think about, like, if you look up here at this scale, a banana is acidic, a tomato and an apple is acidic. So they are technically acidic, but they're not going to burn you. But over time, that small amount of acid can really have major effects on the environment. So just as a reminder, as we continue on, because it's been a lot of notes, we are still talking about effects of urbanization. And so far, we've talked about acid rain, habitat fragmentation, and deforestation. So let's look at a few more. Your urban areas can create what we call a heat island. And yes, you do need to write all of this down. A heat island is basically just a big bubble of heat that forms over a city. Now think about the things that you find in a city. You're going to have a lot of pavement, a lot of roads, a lot of buildings. You're going to have a lot of these materials that tend to absorb heat and keep it there. Think about when you go outside in summer. You could probably walk across your grass and the grass isn't going to burn your feet. But if you step onto the sidewalk or the road, now all of a sudden your feet are going to get burned. And that's that on a very large scale is what you have when you're looking at a heat island. You have all the different pavements that are absorbing all this heat, and it makes the urban area or the city much warmer than the rural outside area that's surrounding it. And as you can see, it can get up to 5 to 9 degrees warmer than the surrounding rural areas, which may not sound like much, but that's a pretty big difference just caused from your pavement. The warm air tends to trap more pollutants, and we already know that we have more pollution within an urban area anyway. And it can also change up some of your weather patterns. But the biggest thing is to understand how and why the urban area is hotter. And that is, again, because of the pavement. But then also, look at what the rural area is made up of. Trees. As you can see in this picture, it has a lot of vegetation and very little pavement. We know from previous units that vegetation actually has a cooling effect on climate, as the plants absorb solar radiation and they perform transpiration. This is just a picture showing you how the differences in weather patterns can be caused because of that convection that happens from those heat islands. But also the graph on the right is showing you how when you look at the downtown area, you can see the temperatures are much warmer. Your suburban or residential area, this would be almost more like a Winterville area versus downtown would be more like a Greenville area, is warmer than the country, but it's not nearly as warm as the main downtown area. And then you can see the rural area is much cooler, especially compared to that initial downtown center. Okay, so let's take a look at your CFCs. So these are called chlorofluorocarbons. This is a form of air pollution that you have released not just in cities, but everywhere. But again, we're looking at urban areas, so you do see a higher concentration of this. They're called CFCs, but no, they're chlorofluorocarbons. You're not going to have to write that out, but make sure you can recognize it by both names. These are really we talked about these a lot when I was in school, and we don't hear about them quite as often because as we've learned about CFCs and the damage they do, they've started to make the things that typically would release them, and they've replaced them with things that won't release them. So it's not as big of a conversation as it used to be. But the issue with CFCs is that they deplete the ozone layer. And so that's a big thing to know. So they deplete the ozone layer. Make sure you know that. When we say deplete, we mean they get rid of or they make holes in the ozone layer. If you remember the ozone layer, it is located in the stratosphere of our atmosphere, and it protects us from UV rays. And so what you don't want is a hole in that ozone layer letting those UV sunlight radiation come through it, because that can cause us a lot of issues. These CFCs are typically released in things like aerosols. So think about like spray paint or hairspray. I'm very bad at using a lot of hairspray, so I'm probably not the best taking care of my environment in that way. But they're also found in old conditioners, and notice I say old, in old refrigerators. The newer refrigerators don't release these like the old ones did. When I was in school, that was the big talk is, you know how you'll go to the refrigerator, you open it, you don't see anything, but you keep staring at it in hopes that somehow, by some miracle, this new delicious food that you wanted will just appear, but it never does. Well, our teachers used to always say, open the refrigerator, look in, take a quick inventory, shut it, think about what you want, and then you can open it again and get it. But they would just preach to not leave that door open, staring for food that's never going to appear. But those are your CFCs. So now let's talk about where all of our trash goes. People all have trash. We produce it. We all have waste is another way you can think of it. And it's got to go somewhere. So after it goes in our trash can, it goes into what we call a landfill. So here you have a beautiful picture of a landfill and your seagulls. They are known as the rats of the sky. But these seagulls, they're just scavenging for food. But you find them a lot in the landfills because there's so much stuff that they can choose from. But when you have these landfills, you have this large area of land that's cleared out of everything. And then the trucks will bring all the trash and they dump it there. It's just a giant dump site for trash. Your landfills will have a liner on the bottom of it. It's almost like a giant trash bag. And that's to help it prevent it from contaminating groundwater. Because think about all that stuff that's in a landfill. Some of it's just gross, disgusting things, the things that were in the refrigerator that you forgot about for a few months. And then some of it is more like your paint thinner or coolant or old chemical cans that you have. And that stuff can be very dangerous. The last thing you want is that pollution, which we call leachate, to leach into the ground. If you remember when we talked about leaching, and that was Leach, this leaching, this is when you have polluted water that is infiltrating into the ground. Issues with your landfills, some you have them leaking the material into the soil and the groundwater, but they try to prevent that the best they can with those liners to provide that barrier. Sometimes it's even a clay liner, and sometimes it's a plastic liner. But other issues are just that it takes up so much room that's not going to be able to be used again. The Pitt County landfill has actually, we filled it up and we have to borrow someone else's landfill just to put more of our trash in there. So the less trash that we produce, the less waste we produce, the more land that we save that we can use for good productive things such as living on or just agriculture. Now some landfills, they actually can cover and cause, they just basically restore them so that all the trash is still there, but they put a liner over it and then some other things, and they can grow grass. And they can actually be turned into things like a golf course. So it's not suitable for you to live on and definitely not to grow plants on, but they could use it for something such as a golf course. And there's stories of these, men who'd go out golfing, and this is back when, you could smoke pretty much anywhere, and they'd have their cigarettes and they'd bend down and they'd pick up their golf ball and there'd be a miniature explosion because of all the methane being released from that old landfill that was under. It would actually cause a little explosion once it got to the flame of that cigarette. Kind of interesting. But I'm going to pause so you can switch to watch the video called Landfills that will be linked on Canvas. And it just talks about the different things that can go into them and how the processing of them works. Hope you enjoyed that video. I just think it's kind of cool. But again, the only thing you really need to write down from this slide is just recycling is one way that we can reduce the amount of waste we have. And that's not only good for saving our fossil fuels, saving our energy, saving our resources, but it's also good for saving the land that we have. Now, I'm not going to leave this screen up very long, but if you want to take a quick brain break, then you can look for the Santa hidden in the Sea of Elves. And good luck finding them. Some people can find them real quick, but if you need more time, you can pause longer. Here's another one. Which of these letters is the odd one out? I'll let you think about it for a second. So the answer, if you don't want to hear the answer, then mute me. But the answer is Y. Y is the odd one out because Y takes 3 letters to draw and the rest take, or wait, was it? I lied to you. It's not Y. I don't know why I said that. It's L. Because all the letters take 3 lines to draw, and L only takes 2. Because you have 1, 2. For A, you have 1, 2, 3. F, 1, 2, 3. K, 1, 2, 3. Y, 1, 2, 3. So L is the odd one out because it only uses 2 rather than 3. So human impact on the environment. Let's keep on trucking. We are almost done. And remember, this is the last notes you have to take for this class. So every year, I've talked about this statistic before, but America, we are only 6% of the world's population, and yet we use 1/3 of the resources and produce 1/3 of the garbage or the waste produced, and that is absolutely crazy because if we're only 6%, we should only be producing about 6%. So that's showing how we really need to make sure we are recycling when we can and that we are being mindful of the things that we use up. I don't know about y'all, but typically if you think of grandparents, my grandparents at least have been they're the type of people who you have the piece of aluminum foil that you bake something with and then you rinse it off and then you fold it up and you put it back in the pantry because you could still use it. And they're very good at reusing their resources and not wasting anything because typically a lot of grandparents were around when there were more wars going on and things like that, and you had to be more mindful of your resources. Since we've gotten away from that and we're just more secure in everything and what we have, we tend to waste more. And so we just need to not take the things we have for granted. But anyway, if you look at how much stuff we throw away 30 million cell phones a year. And this is and 18 million computers, 8 million TVs, and enough tires to circle the world 3 times, which is ridiculous. And some of those things, like your cell phones and computers, they can be taken to different places, and we can reuse the metals and things out of them that are not renewable. So always take your trash to the places it should go. Don't just dump everything into the garbage. Here's a couple pictures just showing you how some of the U.S. was back pre-70s. This is a beach down here at the bottom where, as you can see, there's so much trash and garbage that's washed up because people have dumped so much stuff in the water. Up above, you can see the smog in a city, so a lot of pollution in the air. that obviously none of us want to breathe. And then the last picture on the left is a river that caught on fire 3 different times before we decided, you know what, water shouldn't catch on fire. Let's look at our pollution issues. And so now the question is, what do we do? Conserve. Remember, we're part of the ecosystem and we need to protect it. One way that you do that is reduce, reuse, recycle, and that's through conservation. The definition of conservation is the careful or intentional use of resources. So think about how many times we carefully and intentionally use our resources. Usually we just do stuff mindlessly, but be thoughtful about what you do and what you use. Like when we brush our teeth, turning off the water, that type of thing. So now let's talk about what happened when that river caught on fire for the 3rd time. Basically, a lot of the pollution was getting pretty bad with raw sewage and other chemicals within the water. And this wasn't just in one place, this was all over the country. And so what they did was they came up with this law called the Clean Water Act. This was passed in the 70s. And this required industries to reduce or eliminate point source pollution. Now, we've already talked about this, so you don't have to write it down. It is a review. If you don't even remember it, maybe you should talk about it or write it down. But they basically were saying you can't do point source pollution. You can't intentionally dump all of your waste into bodies of water. You've got to treat it first or dispose of it correctly. Because of this one law being passed, it took the water that was safe to swim in from 36% of the bodies of water in the U.S. to 62% over just passing this one law, not treating anything over the course of 20 years, which is pretty incredible. But that's one of the things that help prevent stuff like all the chemicals being dumped into water, causing it to catch on fire. Now, Safe Drinking Water Act, this is another one that we've already talked about, but just as a review, this one set a max amount of contaminant levels that's allowed to be in your water. So they were saying if you are, giving water to people through the pipes or through bottled water or whatever, then it has to be this clean in order to be considered safe for people. And so that really increased our standards of clean water. Now, the one you haven't written down before is called the Clean Air Act. This one was in the same group, passed in the 70s, but this one was saying that it was basically like the Safe Drinking Water Act, but with air, and it set a set amount of contaminant levels that's legal to have within the air. So there are all these monitoring stations around cities, and if the air gets to a certain level where there's a lot of contaminants that could be considered harmful for someone's health, then the cities have to come up with some sort of a plan or a way to get those pollutant levels down in order to make the air cleaner and safer for people to breathe. So this is one of those regulations that is very important that we definitely want to keep in place. It made that there be new standards for power plants using things like scrubbers if you have a coal factory. It did things like with vehicles, trying to prevent the amount of exhaust that's going out into the air. So, and also encourage people to create things that burn cleaner. So this is a very good law, a very big one. And I've said this before too, but I'm going to repeat it. It was 2 years ago, there were some people from China, some exchange students that came over to the U.S. and they were looking at our education system because they were in school to become teachers back in China. And they went through all these different things at ECU. They toured different Pitt County schools. And at the end, somebody was asking them, what did you like most about America when you came over here? And all of them said how clean the air is. They just couldn't believe how clean our air it was and how easy it was to breathe it. And we don't even think about that. We just think that's normal, but it's not normal for some places. So always be thankful for that clean air and this Clean Air Act. Okay, so I used to say, where's Waldo? But there is no Waldo here. This is where's Santa? So I'll give you a second if you want to look and find Santa. If you want to pause it, you can. So I'm going to go ahead and show you where Santa is. If you haven't found him yet, pause me. But Santa is right here. I'm circling with a white marker. So there is Santa. Yeah, one year I told all my students to find Waldo, and we looked for almost an hour at this picture, and there is no Waldo. And then I realized it was a Where's Santa. But let's move on. That's Waldo, in case you didn't know. This is Waldo. In this next picture, find him located somewhere, and I'll let you pause it if you'd like. Okay, Waldo is right here. Oops. but let me draw right here in the middle. So there's your Waldo. Okay, and try to find Waldo here. I'll give you just a moment. Waldo is located right here on the right of the screen. And I think that may have been the last one. Nope, there's one more. This is your last one. So go ahead and find Waldo one more time. And he is located down here, right there. There's Waldo. Now that really should be the last one. Yeah. Oh, here's some riddles if you want. Tracy's mother had 4 children. The first child was named April. The second was named May. The third was June. What was the fourth child's name? If you want to think about it, you can pause it. But the answer is Tracy, because they tell you it's Tracy's mom. Okay, so let's look at our last couple of slides. We're going to be looking at things that allow us to protect our land resources. So it's going to look at things that can prevent pollution but also manage the resources. So let's look at different ways we can protect our soil. A couple of these things are going to be review. A couple of them are new. But these are some of the 3 big ways that we protect our soil. Well, first of all, we do different soil and conservation practice everywhere. These particular ones, we're looking at how farmers protect their soil. So one is with contour plowing. And contour plowing is what you see up here in the right-hand corner. It looks like a stair-stepping thing. So with contour plowing, you're plowing along the contours of hills or to the sides of hills. And since you're doing the stair-stepping method, it helps prevent the soil from just washing down when it rains. Then you have what we call strip cropping. Strip cropping is what we have right down here in this bottom picture. This is where you plant one strip or one row of corn, and then a strip or a row of something like soybeans, and then another strip or row of corn, and then so on and so on. So you repeat it. You're basically making stripes, and that's what you can think about. Strip cropping almost sounds like stripe cropping. But you have the different plants that all require a different amount of nutrients, or different types of nutrients. So it helps protect the soil that way, so therefore you need less fertilizer. But it also can help prevent erosion, because look at the short crop that they have in the green. This one's very low. The corn is very tall. So that's going to stand up and act as like a windbreaker to prevent erosion with a shorter crop. So it's a very strategic, thought-through way of farming that, again, just helps protect the soil, the nutrients, and also from the soil being washed away. And then crop rotation is something that we already talked about Thursday in our agriculture unit, but that's when you plant one crop in one growing season, and the next growing season you switch it out for a different one. Then you go back to the old one, and then you go back to that different one that you had. And that way, you're using plants that, again, have different soil nutrients, so you're keeping the soil from being depleted of all of a specific nutrient, and that's going to cause you to use less fertilizer. So this is how we protect against erosion on the beaches and the mountains. So in mountains, we just plant vegetation. Remember in our erosion unit, we talked about different ways you could prevent the vegetation. This particular example is kudzu that you see. Kudzu is planted all along the mountainsides because it's a fast-growing vine, but it's also an invasive species, and so it has taken over, and that's why this, kudzu is literally everywhere. And if you remember, the only way to get an invasive species under control is to introduce its natural predator, which in this case was a snail. Okay, and the beach erosion, this is the last, I think, 2 or 3 slides that we have. I promise. So we help prevent erosion at the beach in 2 different ways. One is called hard stabilization, and the examples are seawalls and jetties. And the other way we can prevent beach erosion is something called soft stabilization, and this is a method called beach nourishment. So on this next slide, we're going to look at what a seawall and a jetty is, and then we'll look at what beach nourishment is, and then we'll be done. So a seawall, or let's do a jetty first. A jetty is little bits of like a wall basically that jets out into the channel. So down here in this picture, you can see the current is going this way. You have the beach down here. And so they put these 2 walls sticking out to help soften the current from eroding away the side over here. And you can see that, again, they have the jetty here and the jetty here. And if the current's going this way, it just helps the current to not wash away all the land that's over there. And so these are effective in the short term. So now let's look at what a seawall is. A seawall is just a wall that the waves can crash down onto. That way they're not doing abrasion and eroding and weathering the soil away. And so here's two different pictures of seawalls. You've probably seen these before. But again, it just allows the energy of the wave to just go towards a harder wall rather than a softer dirt, and that way it won't be moved. But again, these are only a short-term solution. Soft stabilization. So seawalls and jetties are your hard stabilization. Soft stabilization is the last one, and this is what we call beach nourishment. Beach nourishment is when you literally get dump trucks of sand and then you just put the sand back onto the beach. So this is not obviously a long-term solution, very short-term, because it will just get washed away anyway. But sometimes you'll even hear resorts that will get the nice white fluffy sand from like the Bahamas or something, and then they will bring it in and do nourishment that way because it just makes their beaches look nicer. But that is what soft stabilization is just dump trucks of sand being added back. Okay, the only long-term solution for erosion is prevention. So seawalls, jetties, and beach nourishment, they're all short-term. The best thing to do is try to prevent it in the first place by having good building practices, and then also doing things like, what are they called? The big grasses, the sand dunes that have the grasses planted on them, leaving those there because the roots naturally help prevent some. Okay, and that is all of the notes. So yay! You are officially done with all notes in earth science. We have nothing new. This video is over. I know you're excited because there's a lot of notes, but we are all done. All that you have left is tomorrow we will review for your test. You'll take that test, and then we will start our review for your final test. So yay, congratulations on finishing all the new notes. Please upload them, and I will talk to y'all later.